Hi students, today we can discuss the chemical properties of carbon compounds. Okay, so first one it is coming combustion. Combustion we know it is complete oxidation. Combustion means complete oxidation. So what happens when you burn carbon? For carbon dioxide, heat and light is produced. The same way when you burn methane, the complete oxidation is taking place. See, you can see that if you burn methane, if you burn ethanol, in all the cases, we are getting carbon dioxide, water, and water, heat and light. Okay, so complete combustion of carbon compounds gives you carbon dioxide and water. That is why they are called a clean fuel. Okay, they are not giving any impurities to the atmosphere. So they form a clean fuel. Okay, so combustion of alcohol, carbon compounds produces carbon dioxide, water, heat, and light. Okay, saturated in that we can distinguish saturated and unsaturated. Saturated means only single bond, unsaturated means double or triple bond may be present. Okay, so saturated hydrocarbons generally give clean blue flame, whereas unsaturated hydrocarbon compounds gives yellow sooty flame. Okay, so uh, you might have seen burning camphor and naphthalene. They're unsaturated and they gives this kind of yellow sooty flame. Okay, and they leaves a residue also. Okay, alcohols is a saturated substance and it burns with a clean blue flame. Okay, and we know we might have seen in the kitchen our stove are burning it and giving clean blue flame, isn't it? Because we are using LPG, the major component of that is butane, even CNG also. Okay, the major component is methane. Both gives blue clean flame like this, isn't it? So they are saturated compounds. This test can be used to distinguish saturated and unsaturated compounds. Okay, what to do? Just burn a little of the organic compound. It gives a clean blue flame, it is saturated, otherwise it is, or it gives, if it is giving yellow sooty flame, it is a unsaturated compound. Okay, that is, can be used as a to distinguish between saturated and unsaturated compounds. Okay, so first chemical property is combustion. Second one is combustion. We have to learn something more. They are talking about so incomplete combustion. Incomplete combustion means uh, if there is no enough supply of oxygen or air is not supplied, not getting properly, it gives this kind of a flame, yellow flame. Okay, so even though we are using a saturated compound, it may result in a yellow flame due to incomplete combustion. Incomplete combustion is caused by insufficient supply of oxygen. Okay, that means either the hole may be blocked or the it is having some other impurities. Okay, if the kerosene stove is giving an yellow flame means its holes are blocked. It is clear. Then blackening of the bottom of cooking vessel indicates that the air holes in the are blocked and the fuel is getting wasted. So coal and petroleum have some nitrogen and sulfur. So their combustion forms oxides of sulfur and nitrogen. They are major pollutants. So coal and petroleum uh, gives out pollutants to the atmosphere. Keep in mind. Now, why do substances burn with or without flame? So certain substances burn with flame, whereas certain substances burn without flame. Why flame? That is produced, or a flame is produced by the burning of gaseous substances. Okay, so candle gives, even though it is a solid substance, it gives a flame because while burning, what happens is the candle solid wax melts and rises up through the wick and changes into the gaseous form. Then it is producing a flame. Okay, and wood and all it is producing flame at first because there is what do you say volatile substances present in the wood. Okay, So they give a flame in the beginning, and later they forms only the charcoal, and they burn without flame. It gives heat only. Okay, and yellow color of a candle flame is due to incomplete combustion of carbon particles. So here uh, carbon is burning because the candle is burning with an yellow flame because there is incomplete combustion of the carbon particles are taking place. So they, while rising up, they glows and they gives a yellow color to the flame. Okay, so that is why the yellow flame is produced in the candle flame. The unburned carbon particles rises up along with the flame and it glows, which gives an yellow color to the flame. Okay, so that is the reason for the yellow color of the flame in the case of candle. Okay, then it is talking some additional information about the formation of coal and petroleum. See, the picture shows that it was at first it were trees and ferns and all. They may get submerged due to volcanic eruptions or some other reasons, and they may form go deep under the earth. And due to very high temperature and pressure, it may change into another form, and after a long time it changes into uh, the deposit called a coal. Okay, whereas coal, we know it is a black colored substance, whereas petroleum and are produced by the dead marine tiny plants and animals. Okay, so dead marine tiny plants and animals sank into the seabed and were covered by silt. So due to bacterial action, they turn into oil and gas under high pressure, and the silt was compressed into rock. The oil and gas seeped into the porous rock parts and got trapped like water in a sponge. So usually we can find these petroleum deposits in the between the rocks, okay, or inside the rocks and all. We can see the reason is this. Okay, then coming to the chemical properties of carbon compounds. Okay, the first property we are talking about, we talked it is combustion. Second one is oxidation. So combustion means complete oxidation. Here oxidation is partial. Okay, so carbon compounds can be easily oxidized on combustion. We saw that, isn't it? And it can be oxidized into, for example, alcohols can be oxidized into carboxylic acids by oxidizing agents like potassium permanganate, alkaline potassium permanganate, okay, alkaline potassium permanganate, or acidified potassium dichromate. Okay, they are called oxidizing agents. See, the equation is like this: the CH3CH2OH in presence of either this or this, okay, alkaline KMnO4 or acidified potassium dichromate, it converts into ethanoic acid or acetic acid. Okay, that means addition of oxygen is taking place, and the oxygen is supplied by either this or potassium dichromate. So they are called the oxidizing agent. Since oxygen is being added, it is called the oxidation reaction. Okay, and see the activity is here is they are asking us to take 3 ml of ethanol in a test tube and warm gently in a water bath like this. Then add alkaline KMnO4 drop by drop. We can see that the color of the KMnO4, which is having a purple color like this, okay, disappears at the beginning and then it remains as such. The reason is at first what happens is oxidation reaction taking place and forms acetic acid. Once the ethanol is completely reacted, then the additional KMnO4 coming down will be retaining as such. So then the color will be remaining. Okay, so that is oxidation of ethanol or ethanol into ethanoic acid or acetic acid. Oxidizing agent is alkaline KMnO4 or acidified potassium dichromate. Okay, so they are called an oxidizing agent. This is an oxidation reaction and they are called the oxidizing agent. Okay, then next reaction, next chemical is so combustion, oxidation, and third is addition reaction. Okay, addition, we know addition is taking place only in the case of unsaturated hydrocarbons. So unsaturated hydrocarbons add hydrogen in the presence of catalysts such as palladium or nickel to give saturated hydrocarbons. What do we mean catalyst? Catalysts are substances that influences the rate of reaction. So it may increase or decrease the rate of the reaction. In many cases, it is increasing the rate of the reaction without affecting itself, without changing itself. The catalyst will not be changing itself, okay, even after the completion of the reaction. Okay, but they increase the rate of the reaction. They are called the catalysts. Here the catalyst can be palladium or nickel. Okay, so this is the reaction equation. See, there is an unsaturation. We can see here. You can see that after the addition, see, there were 4 R. R which means the carbon chain. It can be carbon chain or even hydrogen, no problem. Okay, then we can see that the 4R is there itself. One bond is broken and there 2 hydrogen is getting added up. Okay, and it is becoming saturated now. So unsaturated substance is changed into saturated substance by hydrogenation. This process is called hydrogenation. Why? Because we're adding hydrogen into it, and it is the presence of a catalyst also. Okay, nickel it can be or it can be palladium. Okay, and what is the use of this? Vegetable oils which are unsaturated, okay, can be changed into um, saturated fatty acids like this. And means vegetable oil, see the picture, vegetable oils which are unsaturated having a double bond in it is converted into fatty acids. No hard double bond, okay, saturated. It is called margarine. So vegetable oils can be converted into artificial butter, margarine. What is the process? Hydrogenation. Okay. So that is the use of this importance of this reaction, addition reaction. They are using to make artificial butters. Okay. And vegetable oils are usually unsaturated, so they are supposed to be healthy, whereas animal fats are generally contain fatty acids, saturated fatty acids, so they are supposed to be unhealthy for human beings. Okay, so that is addition reaction, preparation of artificial butter by hydrogenation of vegetable oils, unsaturated vegetable oils. Okay, now the last reaction is substitution reaction. Substitution means it is given by only saturated compounds. Okay, saturated compounds cannot be uh, are not able to accommodate any more hydrogen or any other elements. So if you want to add something, there's somebody should be removed from that. So here what we are doing, we are removing hydrogens, okay, and we are placing in that place we are keeping somebody else or some other elements. Okay, we call it substitution reactions. See, usually saturated hydrocarbons are reactive and inert in the presence of most reagents, but in presence of sunlight, hydrocarbons undergo substitution reaction very fast. For example, say CH4 undergoes substitution reaction with chlorine in presence of sunlight. So sunlight is the catalyst here, okay, forming chloromethane and HCl. See, the picture shows very clearly the substitution. Okay, see the H was here, which is being substituted by one of the chlorines from the chlorine molecule, and see the picture shows chloromethane, which is chloroethane. Okay, it is showing, the picture shows chloroethane only. It is chloroethane which is having a chlorine in place of another one hydrogen, and the removed hydrogen is joining with the chlorine forming HCl, hydrochloric acid. Okay, this is substitution reaction, substituting hydrogen by chlorine in presence of sunlight. So the sunlight is the catalyst here. Okay, higher homologues of alkanes can form many products. So this is only one product joined, so the process may continue, okay, till all the hydrogen gets replaced by chlorine, or it may form if they are longer chains, they form isomers also. Okay, structural isomers, which we discussed in the previous video. Okay, that is also possible due to substitution reaction. Many products you will be getting due to substitution reaction. Okay, now The next topic we are going to discuss is important compounds of carbon. Okay, we need to study only two compounds, ethanol and ethanoic acid. So first we'll talk about ethanol. Okay, in this video we'll be talking about ethanol only. Okay, so ethanol we know it is drinking alcohol, liquid at room temperature. It's a good solvent. So it is used in medicines such as tincture iodine, cough syrups, and tonic, etc. It is soluble in water in all proportions. And we know, see, this is cough syrup, and we can, if you observe or if you read the ingredients very carefully, you can see the percentage of alcohol in it. Okay. Now, the problem with alcohol is consumption of small quantities of dilute ethanol causes drunkenness. Okay. So, intake of even a small quantity of pure ethanol. So, if you want to try pure ethanol, it may be lethal, may cause death even. Then, if you consume alcohol for a long term, that means long term intake leads to many health problems. You might have heard about liver cirrhosis and all, isn't it? So, this is due to the long term consumption of alcohol. Then ethanol for industrial use is made unfit for drinking because otherwise it may misuse. People may misuse it, so uh, they will make it unfit for drinking by adding methanol into it. And that state we call it denatured alcohol. So what is denatured alcohol? It is ethanol mixed with methanol, which is something like a poison. Methanol is a poisonous substance which cause even death, and you may lose your sight also. Eyesight also will be losing if you very dilute amount. If you take much amount, much quantity methanol in consumption, it may cause even death. Okay, so that is denaturing of alcohol. I'm mixing methanol with the ethanol. Okay, poisonous methanol with the drinking alcohol. That is what is called a denatured alcohol. And some countries use alcohol as an additive in petrol since it is a cleaner fuel. Okay, it gives only carbon dioxide. We saw in the first part of this video, isn't it? Burning it gives only carbon dioxide and water, which are not pollutants. So they are considered to be. They are supposed to be cleaner fuel. So some countries use this alcohol as an additive in petrol. Okay. Now, the chemical properties of ethanol. Okay, chemical properties of ethanol. First, we have to study only two reactions. Number one is a reaction with sodium. Reaction with sodium. What to do is take alcohol in a container, drop a piece of sodium into it. We can see that bubbles are coming out. Why it is so? This reaction explains. Okay, here what happens is this H of the ethanol is replaced by sodium metal, and that H will be coming out in the form of hydrogen gas. Okay, and the product formed is called sodium ethoxide. Sodium ethoxide. Okay, so sodium reacts with ethanol, giving sodium ethoxide and hydrogen gas. Okay, so that is the first reaction of ethanol. Number two, reaction with the to give unsaturated dehydration reaction. It is called a reaction with the concentrated sulfuric acid. Reaction with concentrated sulfuric acid. Dehydration is taking place. That means removal of a water molecule. See, this water molecule is being removed by the help of concentrated sulfuric acid. What is this product? Ethene. Why ethene? Because there is a double bond. Okay. So what is the role of concentrated sulfuric acid here? It is the dehydrating agent. Why the name? Because it is dehydrating ethanol to give ethene. Okay. This reaction is taking place at the temperature of 443 Kelvin. Okay. So this is the second reaction of ethanol. Ethanol reacts with hot concentrated sulfuric acid to give ethene. Dehydration reaction. And sulfuric acid is the dehydrating agent here. Okay, so that's the chemical reactions of ethanol. So in this video, we are winding up, And the next video will be having be talking about ethanoic acid and soaps and detergents. Okay, thank you.